Hi everyone, welcome back to Java lesson 08. My name is Tashwanchu and I'm accompanied with my friend Ugen Chinle. Today we are going to learn string manipulation in Java. Today we are going to learn string manipulation in Java. So under string manipulation, we are going to study string class and string buffer class. Now, in the previous lesson, that is lesson 07, we have learned on the packages and modifiers. So, if I give a recap on the lesson 07, uh, what are packages? Packages are nothing but they are just a folder structure uh, that you separate the different modules in your project, and modifiers are the access permissions, and we have four modifiers. We have four access permission modifiers. They are default, public, private, and protected. Now today we are going to discuss on these string manipulations in Java. And on string we have string class and string buffer. Now these string and string buffer classes are present in the java.lang package. So in the previous lesson, we have gone through the packages. So this string and string buffer is a predefined class. So it comes with the Java software. So at the time of Java installation into your system, so these packages will be generated. Okay. Now this string and the buffer class, and there are other classes also. So for this, we are going to study this string class and string buffer class because these two are the most frequently used. Now, so under this string manipulation, we are going to discuss six cases. Okay. We are going to discuss the final class, then approaches to create object with the help of using creating the object with a string, and we also want to discuss on the immutable and mutable nature of the string classes and the string object, and we'll also discuss the tree string method and equals method and conversion of the string, that is uh, string to how to convert string to string buffer and string buffer to string. Okay, so we will discuss these six cases in this lesson under string manipulation. Now, case let's start with the case number one. Uh, Case one. So under case one, let's discuss about the final class. Final class. Now, I have told you that we are going to discuss on string and string buffer classes. Now, where are those string and string buffer classes? So I have already shown you last time. So let me show you again. It is usually it is present in local disk C. For your convenience, I have just taken it here. So it is inside src folder and in the Java and inside this java.lang. Here we have uh, string and string buffer classes, which is present predefined in the Java. It is present in java.lang package. Okay. Now, in the case number one, now for now this string and string buffer classes are present in the java.lang package, and because since I've opened this string class, and we can see here the string class has been declared with a final. This string buffer class is also declared with a final modifier. So therefore, in the time of the inheritance concept, I've told you that if you are giving the class as final, you are not able to extend that final class. So therefore, this string and string buffer is not able to extend. not able to create the subclasses for the string and the string buffer. So this is just for your for your information regarding the case one, the final classes. Okay. Now case two is here string and string buffer classes are final. It 1p 1p extended. Okay. Now case two is uh, here I've mentioned case two is regarding the approaches to create object. Okay. Approaches to create object. Now for this string class, for this string class, for this string class, we have two approaches to create the object. That is, number one is without using the new keyword, and number two is using the new keyword. Now, in the previous lessons, I have told you that object creation. So there are different ways of creating the object. So we can also create a string object without using the new keyword, and we can also create a string object with the help of new keyword. So two approaches to create the string object. Now, now, now how we can create a object, string object without using the uh, new keyword is that, for instance, let's say we have string s1 is equal to, let's say, Tashi, and string s2 is equal to, let's say, Sonam. And we have another string s3, which is equal to Tashi. So this is one way of creating object, uh, string object without using the new keyword. This is for number one. Now, how we are going to create a string object with the help of new keyword is that just string, let's say s1 is equal to new string, then just give Tashi, just copy this, so just say string 2 and string 3, and let's say this is Sonam. Now this is the way of creating the string object without using the new keyword, and this is the way of creating the string object with the help of new keyword. Now I'm going to tell you the difference why we have two approaches, the difference between creating the object new keyword. Now let's discuss this first. Now in entire Java, when you create a string object without using the new keyword, the objects are created in the SCP memory, that is string constant pool. Okay, so when you're creating object this way. So the object are created in the string constant pool memory. Now let's say I've here on PowerPoint. Now let's say we have a string constant pool memory. So this SCP is a type of memory for Java object creation. So SCP is the string constant pool memory, and I'm going to show you the behavior of this SCP memory. Now let's say you are creating the string s1 object. String s1 is equal to Tashi. Here we have string s1 is equal to Tashi, string s2 is equal to Sonam, string s3 is equal to Tashi. Now, how these objects are stored in the SCP memory, I'm going to show it here. Okay. Now, let's say we have a SCP memory. This is the SCP memory. And when we are creating string s1 is equal to Tashi, so this Tashi object will be created in this SCP memory uh, with a reference variable s1 pointing to the object with the content Tashi. So this is the behavior. You are creating the second object, that is string s2 is equal to Sonam. Now, before creating the object in this SCP memory, so it is always checking if the object with the content Sonam is already present in the memory or not. Now, if it is not already present in the SCP memory, then new object is created with the content Sonam, where a reference variable s2 uh, pointed to the Sonam. So Sonam object is created, new object Sonam is created since Sonam is not present in this SCP memory. So S2 is pointing to Sonam. Now the third object, it's when we are creating the string S3 is equal to Tashi. Now first, it will check if the object with the content Tashi is already present in the memory or not. Now if you see here, so Tashi is already present in the SCP memory. Now, since content Tashi is already present in the SCP memory, it is not going to create a new object. Instead, it will reuse the previous object, where reference variable S3 will point to the previous object Tashi. So this is how SCP memory is behaving. Okay. Now this is regarding the object creation without using the new keyword. So if you are creating the object without using the new keyword, then the objects are created in the SCP memory, where the point that you have to remember is in SCP memory, it is always checking if the previous object is present or not. And another point that you have to remember is SCP, that is string constant pool, to not allow duplicate objects. So if there is duplicate, it will point to that previous object. So this is the behavior of the string constant pool memory. Now, in this, that's all with this creating object without using the new keyword and behavior of object creation in behavior of behavior of these objects in the SCP memory. Now, the second one is uh, using the new keyword. So when you are creating objects, string objects with the help of new keyword, then uh, then these objects are created in heap memory. Unlike the first one, now when you are using the new keyword, the objects will be created in heap memory. Now in entire Java, when you create string object using the new keyword, the objects are created in the heap memory. So in heap memory, it won't check the previous object. Instead, it is going to create all three separate objects. And the point you have to remember is heap memory allows duplicate objects, duplication of the objects, and it will not check for the previous objects. Now the behavior I'll show you here in this PowerPoint. So heap memory, creation of the string object with the help of new keyword. Now let's say this is the heap memory. Now when you are doing string s1 is equal to new string with the content Tashi, it will be created with S1 pointing to the object with the content Tashi. Now, when you are creating another object that is S2, string S2 is equal to new string sonam with the content sonam. Again, the content is created without checking the previous whether it will not check whether sonam is present in this heap memory already or not. You will directly create sonam with reference variable S2 pointing to sonam. Now, when you are doing S3 is equal to new string Tashi, then another Tashi object will be created in this heap memory without checking for the previous object. So therefore, and I mean this S3 pointing to Tashi. Now, if you see the difference between the string constant pool memory and the heap memory, so we can see here clearly that in the string constant pool, duplication is allowed. Duplication is not allowed. In the heap memory, duplication is allowed. So here we have two Tashi objects being created. So this is the difference between creating object using the new keyword and without using the new keyword. So this why there is this kind of concept is because it is required in the project developments. Okay. Uh, I think that's all with the approaches to create a string object that is without using new keyword and with the help of new keyword. Now, we have another class that is string buffer. Now, to create the string buffer object, there is only one approach, that is with the help of using the new keyword. So, as I have already told you, when you are creating the object with the help of a new keyword, it will be the object will be created in the heap memory where it will not check for the previous object and where duplication is allowed. So let me just show you one example regarding this creating object of the string. Let's say we have just remove this. Let's say we have class test and let's say we have let's see and let's create a string object here. Str and string s1 is equal to, let's say we have Tashi. Let's just copy this. Now let's say this is the second object s2 with the content sonam, and we have Tashi reference variable s3. Now let's try to print those uh, so I mean let's do this afterwards. So just let's do the simple example here. So let's just print system.out.println. Then let's say we have s1. So this first approach is creating the object without using the new keyword. Now the second approach is let's create a string object, let's say s2 with the help of new keyword. This is how we do. And let's say we have something like in here, and let's try to just copy this. Let's just try to it here, and let's try to print s2. And these are the two approaches to create a string object, and we have one approach to create a string buffer object, that is string string buffer sp is equal to new string pu string buffer object. Let's say we have content. Let's just try to copy paste the previous, and let's say we are printing sb. So this is just the approaches regarding this case 2. I'm just showing the simple example, creating the string object two approaches in creating the string object and one approach is in creating the string buffer object. Now let's save this and let's try to run this code. Okay. It is in CD Java training. CD training. Yeah, training practical. Just clear this. The function has to. So we have a test class here. This let's compile. Compile successfully. So we have the test class. Now here we are able to print. So this is the three ways of creating the object. String we have two approaches and string buffer we have one approach. Now with this I'm going to give you the information regarding this equal to operator. Under this case 2 we have this operator. We have this operator, okay, equal to operator. Now what does this equal to operator, so what is the link? So this equal to operator deals with a string only, so that's why I want to discuss equals to operator. So yeah, my friend has already discussed regarding these operators. So now when it comes to this equal to operator, it is dealing with a string object. Frequently it is used in the it is used to deal with a string. So let's try with the um, above objects. So here I've already told you that this, let's try to compare these different objects, three objects with the help of equal to operator. For this without using the new keyword. Now let's say when we do s1 equal to s2, so what it will be? So this equal to operator return type is always boolean, okay? So when we do s1 equal to s2, what it will uh, return is that, so here if you see s1 and s2, so what this equal to operator does is that it does reference, it does the reference comparison. Now here if we see, I mean here if you see s1 and s2, instead of comparing this content Tetashi and Sonam, so with the help of this equal to operator, it will compare the reference variable. So how it will be checking is that, since when we are creating the object without using the new keyword, it is created in the SCP memory. So we have seen that. So when we are creating this S3 object, that is Tashi, so it is referring to the previous object Tashi, and it is pointing, this S3 is pointing to the Tashi, that is previous object. Now if we see here, when we are doing S1 is equal to S2, so this S2 is pointing to different object and this S1 is pointing to different object Tashi. So that's why is going to return false. Is going to return false. Now if we do S1 equal to S3, now what will be the return type? What it will return is that, if you see here, we have S1 and S3. Now we can see that S1 is pointing to object Tashi. Now if you see here, S3 is also having the content Tashi. Since they are having the same content, so this S3 will be pointing to the same object Tashi. Since these two reference variable S3 and S1 is pointing to the previous object Tashi, so it will return true. So it is regarding this diagram here. So S1 and S3, S1 and S3 is pointing to same object Tashi. So that's why it is returning 2. Since S1 is pointing to Tashi and S2 is pointing to Sonam, that is S1 and S2 is pointing to the different objects. So that's why it is returning false. So if we do S3 equal to S1, then it is also going to return false. Now this is so this is the approach. Now for this approach, that is creating the string object with the help of new keyword. Now when you deal with this equal to operator with this object with a new keyword, the behavior will be different. So this is always heap memory, and this means always STP memory. Okay, so just remove this. So let's check for this string object with a string object created with a new object, new keyword. I mean. Now let's try to compare S1 equal to S2. Now if you see here, this is the heap memory. So when we create the string object with the help of new keyword, the objects are always created in the heap memory. So in the heap memory, so the behavior of the heap memories I've shown you here. Tashi object is already there, but when you are creating the same object Tashi, it is not going to refer to the previous object, just it will simply create the duplicate object here. So that's why, so these are pointing to the independent object. So in entire Java, when you are dealing with this equal to operator with object creation with a new keyword, it is always going to return false. So here we have seen that in the entire Java, so this reference variable will never point to the same object, and it will point to the independent object. So that's why in the entire Java, so this will be always false. When you will, if we do S1 equal to S3, so this will also return, this will this will also return false. Now if we do S2 equal to S3, this will also, this is also going to return false. So this is just some of the points that you have to remember the behavior of these string objects, the STP and the heap memory. Well, we're done with this case 2, that is approaches to create string object. Now let's discuss the case 3. Okay. Now case 3 is regarding the immutable, the immutable, and mutable nature of the mutable nature of the string and the buffer buffer class. So in this case 3, let's discuss the mutable and immutable nature of the string and the string buffer classes. Now for your information, so once you create the string object, then the data is fixed and cannot be manipulated or modified. Okay, this is the point that you have to remember when you are creating the string object. that data is fixed and it cannot be manipulated. Now, whereas when you create the object with the help of string buffer, so that object can be manipulated or modified. Now, here the mutable nature and immutable nature of the string and string buffer comes. So, for this immutable and mutable nature of the string and string buffer, I'm going to explain you with the help of one simple program. Okay. Let's see. We have let's say we have class test, and let's just remove this. Let's check for the immutable nature of the string. So this this behavior is called immutable nature. Now let's create one string object. Let's say s1 is equal to, let's say we have a sheep. Let's try to modify this s1. So let's try to concatenate something to this s1. Let's say we have s1 dot con cat. So this concate is a predefined method which is present in the string class. Okay, this is predefined method. Now let's try to concatenate some string here. Let's say I'm going to concate function. It's just to show the uh, mutable nature and immutable nature of the string classes. Okay, so here we are creating the object Rashi, and here we are trying to modify or manipulate this string object. That is, we are trying to concatenate something to this Tashi. That is, we are trying to concate this Wangchuk to Tashi. Now let's try to print this system of output and let's try to print this S1. Now we can guess the output here. So and let's say we have let's try to create another object with the help of I mean for the string buffer, that is string you have a string buffer sp is equal to new string 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 buffer. Then let's give the content as common. For this string buffer, we have a predefined method that is append. So inside string buffer, we don't have concate. So we have append method. So let's try to append sonum. Let's try to append one to here. And let's try to print. Let's try to print this as B. And guess the output, okay? For now, just remove this. I'm going to explain you. So just save this and let's try just save this. So what we are trying to do is we are creating the string object here, and we are trying to create another string buffer object with the help of new keyword. So this is only the single approach. We have only one approach to create the string buffer object, and we have two approaches to create this string object with the help of using the new keyword and without using the new keyword. Now let's check the behavior of these two. So this is the string object, and let's see whether we are able to modify this string object, and this is the string buffer, and let's see whether we are able to modify the string buffer object. Just save it and let's try to. Now our assumption is that, so immediately our assumption is that when we are doing the concatenation here, Tashi Wangchuk will be printed. Then here also Sonam Wangchuk will be printed. So this is our assumption right now. Now let's try to check it here by compiling and executing. Java C test Java execute now test class. Now if you check here, so this is our output. So if we paste this output here, so we can see here it is only Tashi is being printed, whereas this Wangchu is not mentioned here, not reflected here. But whereas for the string buffer, when we are creating the object with a string buffer, we are able to modify this behavior. For this, so this this behavior is called immutable. IMMUTAB, immutable. This behavior is called immutable nature, and here the output is Tashi. So we are not able to modify this string object. Now whereas when it comes to the second object, this behavior is called the mutable nature of the class. Okay, string class. So here we are able to print Sonam Wangchu. So this is just to show this the string behavior, that is immutable nature and mutable nature. Now in your college days, if you have performed exams in Java and also you might have given the question regarding this immutable nature and the mutable nature to answer. So if you give this simple code, then I think it's fine. So it means that you understand the meaning of this immutable nature and the mutable nature of the string class. Okay, so these points you have to remember. It's important. Now I think we are done with this case 3. This is the case 3. Yeah, I guess this is case 3. Yeah. Now in the case 3, we have done this simple example. Let me just paste this here. So I hope you have understood what is this immutable nature and a mutable nature of the string and string buffer classes. Okay. Now let's discuss the case 4. Uh, in case 4, so what we are going to discuss is, so what is here? Let me check here. Case 4 is about toString method. toString method. Case 4 is regarding the toString method. Now, in Java, whenever we are printing the reference variable internally, we are calling the toString method. So this is the point that you have to remember. In Java, whenever we are printing the reference variable internally, we are calling the toString method. So in the previous examples, here, when we are printing this reference variable s1 internally, so let's just try to remove this code and show you clearly. Let's say we have object string s1. Okay, and we are trying to print this system dot out of println, and we are trying to print s1. Now let's check the output. Okay, let's check the output. What's the output for this code? Initialize. So let's try with string new string. We have to initialize. It's just a simple example just to show this calling of the toString method. So dash is being printed. Now how it is happening is I'm going to explain you here. So whenever you are doing this, so let me write another statement. So whenever we are doing this, whenever we are trying to print this s1 reference variable, so it is internally calling the toString. It's internally calling the toString method. Okay, let me check. So the output for this and this will be same. Let's just check it here. So dash is being printed. Now the conclusion from here is that, so here what is happening is when you are executing this statement, what is happening is this will internally call the toString method. This will internally call the toString method, which is present in the string class. So if we check here, so this is the string class. It is inbuilt Java string class. Now if we just find toString class here, you just try to find it here. So here we can see this toString class is present in the string.java. That is in the string class. It is present in the string class. So the point here is that here. So when you are trying to print this s1 internally, this will internally call the toString method, which is present in the string class. And here it will also happen the same. For this we are using unlike this one, so this will internally call without our notice. But for this, if we are trying to call toString method, first of all, it will check whether this toString method is present in this class test or not. It will check whether this toString is present in this class or not. First, it will check. Then only, if this toString is not present in this test class, then only it will call the toString method, which is present in the string class. Okay, so this is the difference that you have to remember. So when you are doing this uh, when you are doing this internally, it is calling the toString method, whereas for this it will first check whether toString method is present in the test class or not. Then only if it is not present in the test class, then only it will call the toString method which is present in the string class. Okay. Now let me discuss another example, another simple example. So this is a very simple example. So just let's say we have a student class, student student class, and let's say we have let's say we have int sid student id, then string string uh, as name. Okay, and let's say we have constructor student student constructor, and this student constructor is accepting two parameter, let's say sid and string string name. So let's try to make these local variables. So these are the local variables, right? We have already discussed. So let's try to make it global. How we make this local variables global is we make this dot sid is equal to sid is dot as name equal to as name. So this is how we are making these local variables global. So this is the instance variable and this is the local variable. Now let's just remove this. It's not required. No. Now let's create the student object. Student std is equal to new student. Now this student, we have a constructor. So this is the constructor, and we have two parameters here. So we have to pass the parameter. We have to pass the values. Let's say we create 20. So this is the student ID, and let's say we have student ID, and let's say we have the student. This is student name. We have the student name as um, Tashi. Okay. Now let's try to print those values. That is ID and as name. So we have std, and again let's try to do same as the before. That is std dot to string. So in the previous examples we have just practiced with this approach. So we have done that because this is not mandatory to do. That is not mandatory to call the toString method. Internally, this will be called by the JVM. Okay. So these two statements are same. So it will perform the same operation. Whether you call this toString or not, it will perform the same operation. So this is I'm declaring here. I mean calling this toString method here just to show the behavior of this toString, how it is called internally. Okay. Now let's try to execute this. So just guess the output, whether it will print 2820 or trashy. So just guess the output. So let's try to compile this. Okay. So let's try to compile this here. Java C, we have file as test.java. Now we have Java, and we have class name student. So see here, we have a different output. So just copy this. We wanted to analyze this output. So what happens is when we are trying to print these values, we are given with a different output, that is student at the rate. Now what happened here is that what happened here is that so this is the class name at the rate, this is the hash code. Now hash code is being printed for this example. Now our objective is to print 2820 and Tashi, but we are given with this output. Now why we are given with this output, I'm going to show it here. Okay. Now when you are trying to print the object reference variable, so this toString is calling the this toString is calling from the object. So this is the inbuilt class, it is object. So I have in the previous lessons I have told you that a root class of all the classes in Java is the object. So this object class do not have the parent class, and I've told you that all the classes in Java, the root class is the object class. This is the parent class of all the object class. Now if you see here inside the object class we have toString method. Now what happens is here when we are trying to print this std here, internally it is calling the toString method of the object class here. So therefore what it will do is, what this toString method in the object returns is it will return the class name. Here we have a get name, here get class dot get class name at the rate and then integer, that is hexadecimal, some values is being printed. So same is here, that if we check this output we can see this is the student, this is the class name. Here we have uh, here we have here 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 we have the first we have the class name, then it is printing the at the rate and then some number is letting to print. So therefore here class name at the rate some hexadecimal number is being printed when we are trying to print the reference variable of the object. So this toString is internally calling the toString method of the object class. So that's why it is printing the student at the rate some hexadecimal number. Now you might be wondering what are those hexadecimal numbers. Now those numbers are nothing. So I've just related a simple example. So just here we have SID. Now in a school different students will be having different SID. Okay, so it is now with the help of this SID, so you are able to uniquely identify the students. Now same applies to these objects. So when you are creating different objects in Java file, so these objects need to be verified uniquely. So therefore JVM will assign unique hexadecimal number for these objects. So that's why it's a hexadecimal number. It is very similar to that of the student ID and all, employee ID, similar to that. So just to identify the objects uniquely, so they are assigned with the unique hexadecimal number. Okay. Now we have a problem. So we want the data to be printed here, but we are printed with the default value that is student at the rate some hexadecimal number. So this is not required. Now what we have to do is that in order to, so the ways that we can print our real data, the real world data. So we want the real world data in our application. So therefore how we can get this real world data, that is 2820 and Trashi. Now in order to do that, what we have to do is that we have to define a toString method inside the student class. Now how we will do is we just have to do this. We just have to declare toString method here, PUBLIC. So let's say this string is public and let's say string toString method string. And what we are doing is, so this string returns always returns string. So the this toString method return type is string. So it returns string. retu. So it returns, let's say, sid, just give space, sid, let's say we want sid to be printed, then we want mm, s name, so s name is plus s name. So this is, we are trying to call the true string inside the student class. We are trying to declare the true string. So here the behavior is that when you are trying to print the reference variable std, what will happen is, so I have told you already, no? So that when you are trying to do this std or std.toString, first it will check whether the toString method is present in the class or not, within the class or not. So first it will check whether this toString is present in the class or not. So if it is not present in this student, it will call the object toString class. So whereas here we have toString class declared here. So therefore this toString will be called and it will return the real world values. So let's just save this and let's try to compile and execute. Java, compile successfully. Java, so we have class student. So here we are able to, something is wrong. We are printing null. Let me check. It's not supposed to be null. It should be Tashi. So what went wrong? String SID. This name is null. Let's try to fix this. I think I've done some mistakes here. We are trying to create object here. So student class stds name as id. So I'm not sure why I'm getting null here. It should print Tashi here. So I'll come back to you on this, why it's printing null. Okay. So I'm not sure why it should print Tashi here. So we have, so just to show, this example is just to show how we are calling this true string into when we are declaring the true string method inside the class, student class, and then um, internally calling the true string class to the object. Now, if we analyze this output, Control C, so if we print, if you just copy it here, so what it is trying to do is this. It is trying to do here is that when you are trying to call the true string here, you are just calling the true string method which is present in the student. So it will not call the true string method which is present in the object and the uh, string class. So this just to show this case is. Now let me do another example regarding this. Let's just remove this. Let's say we have string object, string s1 equal to Tashi. Now let's try to print s1. And let's say we have s1 dot true. So this should be, so let's we are creating string object s1 is equal to Tashi, and then let's try to create string object string buffer str in the string buffer. String buffer sp is equal to new. I think we have made some changes here, so it's giving error. This. Let's try to give the content as sonam, and let's just try to print this spn sp. This is the example in continuation with the previous example, okay, for this true string. So we just wanted to check the behavior. Now let's just save this and try to compile and execute. Take here. We are calling the method. We have to put two brackets here. Let's see with chess class, not student class. So here we are able to print tashi tashi sonam sonam. Just analyze this here. Now what happens here is this. Let's just copy this code here in this board. This is regarding the case 4. Now what happens here is that when you are trying to do this s1 dot toString or s1, when you are trying to print this reference variable, so which toString method will be called when we do this is that it will call the toString method of the string class. Okay. Now what is toString method? This toString method is present in the string and it is overridden from the object class. So this is just information. So this toString method is override from the object class in the string class. So when you are trying to call the toString method, so it will call the toString method of the string class, and then what it does, it does the what it it returns is that it returns the content of the reference variable. Now, unlike the previous example, when you are trying to print a reference variable for the object, and when you are trying to call the toString method of the object, it is doing the it is returning the reference, that is the class name and the hash code. Now whereas when you are trying to call the toString method of the string class, which is override from this object class, so when you're trying to call this toString of the toString, so it will just print the, or it will return the content of the reference variable. Here we are able to print tashi tashi and sonam sonam because we are because this toString, the string class toString method is being executed. So same is for here. The same happens for here, that toString which is present in the string buffer class will be executed. I think that's all with this case 4. Now, from this case 4, that things that you have to understand is that if the object class, that is, if object class toString is executed, so both the object and the string class contains the toString. Now, if object class toString is executed, then the output is class name plus hash code is printed. So if string class toString is executed, then content of the string is printed. Okay, this is just the difference between the toString, the behavior of the toString which is present in the object and the string class. So I think we are done with this case 4. Now we have another case, that is case 5. Let's discuss case 5. Now in case 5, we will discuss the um, equals method. Now for your information, where are those equals method string? I've already told you that these methods are present in the predefined classes, that is object, string, and the present in Java line package. It's predefined. So when you are doing the Java coding, those inbuilt methods will be used. So here we are in the case file. Let's discuss equals and equals method in Java. Now this equals method is also related to string only. So it is for computation of the string reference variables. Now I will just verbally tell you there's some few points regarding this uh, equals method. So you can just so if you're not uh, I think if you're feeling heavy, like if you're not understanding right now, so I urge you to watch this uh, video again when you reach home, or you can just Google out. So I think you will be able to understand it better if you watch one more time, because it's not easy to understand at the first time. So I want you to watch this tutorial one more time. I'm just going to say the points verbally here, and you can note down, and if you can make note, then it will help you. So regarding this equals method, the first point is that now this equals method is frequently used in the project development, so it's very important. So every basics of Java is important. So that's why you should not miss the small points also. So the first point regarding this equals method is that equals method returns the Boolean return type. The return type for this equals method is it returns Boolean, that is true or false. Now the second point is it returns true or false. Now the second point is equals to method compares the reference variable. Now when it comes to now I've told you that the equals method is present in the string and object class. So these are the predefined classes which is present in java.lang package. Now if when you deal with the equals method which is in the object class, then this method compares the reference variable. Now when you deals with this equals method with a string class, then this equals method compares the content of the reference variable. So if you are not understand it now, as I told you, you just note down the points. Equals method compares the reference variables when you are dealing with the object, and equals method compares the content of the reference variable when you are dealing with the string class. And if two reference variables are pointing to the same object, it returns true, otherwise false. So I think you have got the point. These 4 points. Equals method returns the Boolean return type. Equals method compares the reference variable when dealing with the object. And equals method compares the content of the reference variable when dealing with the string object. And if two reference variables are pointing to the same object, then it returns true, otherwise false. So let me just give you an example regarding this equals method. Okay. So example, let's just remove this. Not be good. Now let's say we have class test, and let's just create one constructor here. So just declaring the constructor with one parameter str and string str. Now let's try to create the test object. T1 is equal to new test. Now this is the test class. We have one constructor and it is accepting one parameter. Let's say sonam. Let's create another object. T2 another object, and we're trying to print. So just to show the show how this equals method, which is present in the object and in the string class, behaves. Okay. Now let's compare this T1 and T2. Okay, T1 and T2. This is object level. I'm going to explain now. Well, yes, T1 dot. So you compare equals equals. Then you are comparing with the T2. So this is the first approach. So let's discuss one by one. So let's just try to see what is the output of this code. Now, guess what is your answer here? Now immediately what you are thinking is that here T1 and T2 have the content sonum and sonum, and you might be thinking that true will be printed. So let's just check whether it is true or not. Java test. So our assumption is wrong, so it is printing false. So our output is false. Now I'm just going to explain why it is false. Now just before that I have told you that, so what we are trying to do it here, when you are creating the object with a new keyword, I've told you that now what does heap memory does is that even if the content is same, different objects is being created in the heap memory. It will not refer to the previous object. So this is the point that I have already mentioned you regarding the heap memory. Now what happened here is that when you are trying to do this comparison, equals comparison with T1 in T2, so when executing this statement, first it will check if the current class content equals method. It will check whether this equals method is present in this test class. Now, if it is present in this test class, then it will execute the equals method which is present in the test class. But here we don't have the equals method inside this test class. Therefore, so this is, since this is dealing with the object class equals method will be returned, or object method equals will be called. Now, since T1 and T2 are pointing to different objects, so I've told you that when we are creating the object with the help of new keyword, so it is storing in the heap memory. It is storing in the heap memory where the reference variable are independent. So it will not refer to the previous object where duplication is also allowed. So therefore, two separate memory is being allocated, and I have told you that this equals method which is in the object is doing the reference comparison. Reference comparison. Is that it? So I have told you that when you are calling the equals method which is present in the object, it is doing the reference comparison. So since these T1 and T2 are pointing to different object, so that's why it is returning the false. Since T1 and T2 are pointing to different object, it is returning a false. So this is the point regarding this example. Now let's see another example. Let's check it with a string. So here we are trying to call the equals method which is present in the object class. Now let's try to call the equals method from the string class. So let's try to create a string object here. String s1 string s1 is equal to new. Let's not use new. Let's just all without using new. So let's say we have Tashi. Let's say we have string s2 is equal to Tashi. And let's try to compare these two, S1 and S2 here. S1 and S1 and S2. So let's try to compare this. So your immediate answer will be false, because here we are getting false. So let's check it whether it is false or not. Let's check it here. Let's just try to compile and execute. Compile success. Let's try to execute. So our assumption is wrong. It is true. Now, why it is true? I'm just going to explain you here. So our output is true. Now I have told you in the previous. So these are all linked with the previous examples. So when you are creating object with the help of without using the new keyword, it is these objects are created in the SCP memory, string constant pool memory. Now since the content is same, so this S1 and S2 will be pointing to the same object Tashi. So that's why what happens is when you are calling the equals method, instead of calling the equals method which is present in the object class, it will call the uh, equals method which is present in the string class. Now this object class and string class, I've told you it is present, it is the uh, predefined classes in Java. Now I've told you that the object class equals method does the reference comparison, whereas equals method which is present in the string class performs the content comparison. So since here Tashi and Tashi is same, so it is giving the true return type. So here I've explained you why we are getting the false because of the heap it is referring to. So here the equals is calling the object class equals, so that's why it is doing the reference comparison since it is not pointing to the same object, so that's why it is running false. Whereas here it is calling the equals method which is present in the string class. Since the equals method which is present in the string class does the content comparison, since we have Tashi and Tashi, it is returning the true. Okay. Now, now this is just to for your understanding. I'm just writing it just for you to remember. Object class. So object class equals method is called for this, and it is comparing the reference variable. Unlike for one, for here, it is string string class equals method is being called, and what this equals method in the string does is that it does content 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 comparison. Now we have another class that is string buffer. Let's check for the string buffer. String buffer sp, let's say sp1 is equal to new. So this is with the help of string buffer. This is the only approach to create the object by using new object. There is no other methods to create a string buffer object. This is just for your information. So let's say we have content sonum. Sonum. Let's just try to copy this. Let's say the reference variable is sp2, and you have the same content. Now just guess the output. So your immediate answer will be it will return 2 because we have same content. So let's just check it. So, I forgot to print here. I forgot to compare here. So let's just compare sp2 and sp1 and sp2. So our assumption is it will return true. Let's check whether it's true or false. I forgot to save it. Let's save it. Java C. Java. So we are getting the false. Why we are getting the false? The explanation is same as what I've given here. So for your information, for the string buffer, now for this, I mean, let's start from here. String. This equals method is override from the object equals method. So these are already predefined by James Gosling. So it's already predefined. Okay, when they are developing the Java, they have developed this way. So this equals method in the string class is overridden from this object class. Now, unlike this string, in string buffer, this equals method is not overridden or override. So what happens is this is not true. Now our return type is false. We have checked with the compilation and execution, right? Now, for just for your information, for this string buffer, we don't have the equals method. Now, what happens when we do this is internally or by default, equals method of this object class will be executed. So what does the equals method of the object class does is the reference comparison. Since we are creating the object with a new operator here, a new keyword here, I mean new keyword. So these objects are created in the heap memory. So therefore, these two SB and SB1 and SB2 are pointing to different independent objects. So therefore, it is giving false. So I think hope you have understood regarding this. Now, I think this is the final case, that is case 6. Paste this for reference. Let's say we are done with this case file. Now let's do case 6. We're almost done now. Now case 6 is regarding the conversion. Now conversion in the sense how to convert string to string buffer and string buffer to string. So these two we will discuss with the example. Okay. Just remove this. Let's see we have uh, let's say str string is equal to trashy and string buffer is b new. Let's see we are trying to print str. So this is how we are. So this example is, let's just type it here, conversion of string to string buffer. How we can convert string to string buffer. So here we have a string object Rashi. So how we are going to convert this string object to string buffer is just by this line, that is string buffer sb new string buffer. Just give this reference variable here. By default it will be converted into string buffer. So in the previous just before this I have told you that this string class cannot be modified. So since this is the immutable nature, so and this string buffer is the mutable nature, we can't modify this string. Once it is declared, we can't modify this string object. So in order to modify this string object, we have to convert it to the string buffer, and then we have to do the modification for this string. So let's say in your, so when these things will be required is, let's say in your project you might be having a requirement like you have declared one string and you want to reverse this string. But when you are trying to reverse this string directly, you are not allowed to modify this string. So how you will do is, you will just convert this string that is already present into string buffer, and then we can do the modification. So here I'm just declaring the string trashy. I'm creating the string object, and then I'm just um, converting this string to the string buffer with this line, and then I'm trying to reverse it. So how we can do the reverse is sp dot revtr sc reverse, revtr sc reverse. Now this reverse method is also present in the string class. So these are already predefined at the time of development of the Java. So these are the predefined methods that we are using. So let's try to save this and try to execute whether we are able to convert this string to string buffer. Java yes. So here we are able to modify, we are able to convert this string, and we are able to do the reverse. So this is the conversion of string to string buffer. Now the second one is, let's do for conversion of string buffer to string. Let's just see, we have one string buffer object here. This is string buffer to, let's say we have one content, we have sonam. Let's say we have sonam here, and we want to convert this string buffer to string. So how we will do is, just so this string returns string, declare string, give one reference variable str1 is equal to, just, so let's say we have this is sp1, just do sp1 dot to string. So just call this to string method, it will convert it to string buffer. Now let's just try to print this. So this line is how we are converting this string buffer to string. So after this sonum will be not able to modify after this line. Till here, it will be able to modify. It is the mutable nature of the string buffer class. Now let's try to print this. It's not reverse. Think, directly printing this is str1. So here we are able to convert. We are able to do the conversion. So I think that's all with the string conversion. Case 6. So we are done with this case 6, and I've also told the requirement of this string conversion and all. Now I want to discuss some more points. So we have a few minutes left. So let me just cover a few points. That is, let's discuss on this. Uh, so till here we are done with the 6 cases regarding this string and its string buffer, the string manipulation. Now for your, just for more information, I'm just going to give some few informations regarding this equals versus this equal to operator. Now regarding this equals versus this equal to operator, so this is the frequently asked questions in the exam, or if you're attending an interview for Java. So if you're asked to uh, give the difference between this equal and equal to operator, so you have to know this. So it's all very important, knowing the difference between this equal to operator. So if I share one of my experience, so in one of my interview, I was asked to tell the difference between this equals method and this equals to operator. What I have told them was I've told him that this equals is a method and this equal to is operator. And the another point I told him was this equals to operator will be used in advanced level, and this equals to operator he will use in a normal way. So the interviewer was giving a strange smile and saying okay, okay. But luckily, I think my answer was not up to his expectation, looking at his strange smile. So therefore, if you are into my same place in future, so you should not be telling this is a equals method or this is a operator or this will be used in the advanced level or this will be used in a normal level. Okay, so you should understand in depth meaning of this equals to method and this equals to operator. So the difference between this equals to method and equals to operator is that now this equals to, so you should say it something like this. These equals to methods are present in the object class, which performs the reference comparison. And another point that you have to tell is that equals methods are present in the string class, which performs the content comparison. If it is in the object, it contains reference comparison. If it is in the string, it performs content comparison. Now, with string buffer, it performs the reference comparison. Okay, so this is the points regarding this equals operator. You should be saying that way. So this equals method is present in the object class and it performs reference comparison. And this equals method is also present in the string class and it performs the comparison. And regarding this equals to operator, so you have to say something like this. Now equals to is an operator which performs the reference comparison. In the entire Java, this equals to operator will perform the reference comparison. It will never perform the content comparison. So this should be the answer. This equals versus uh, equals method versus equal to operator. So this is very important interviewer or in the project level or in any exams that you perform or you are attending. So you have to know the difference between this equals versus equal to. This sounds very similar. Equals. Okay. Now another point that I have to uh, let you know is the regarding this length was I mean length versus length method. Now, for your information, this equals method, this length, these are all predefined methods which are present in the Java.lang package. Okay, maybe it will be present in object class or string class or string buffer. There are 100 plus methods which is present in those string and object. Okay. Now, regarding this length versus length, so this was the second question that I was asked in the interview. So now my answer was similar to the upper one, that is length is a variable, then this length is a method. So this should not be your answer. Okay, so you have to understand in that. So your answer should be something like this: length is a variable. So it's very similar, no? It sounds similar and we have to know the difference. So this length is a variable which finds the length of the array or the size of the array. So this variable, what does the function of this length is? It will find the length of the array or size of the array, whereas this length method is a method which finds the length of the string. So let me just give a simple example regarding this length and length. So I think this is understandable. So let's say always class test. We have a class test. So let's say we have one. Let's declare one. Let's declare one in array. So this area it will cover in later classes. Okay, so if you're confusing what I'm doing right now, just don't worry. It is really covered in the later classes. Area is equal to new and int int 200. And let's try to use the length variable to find the length or the size of this array. So SOSTM system.out. So just here dot. So this example is length versus length method. Now for the method, let's declare one string. String str is equal to, let's say we have Tashi. Now we want to find the length of this string. So how we can find the length of this string is by using the length method. Just do str dot length. Just save this. Let's try to execute. Compilation Java test. So we are able to see the difference between this length and the length method. So this length variable, it is used to find the size of the area. Our size of the area is 200 and our length of the string is 5. So if we count here, 1 2 3 4 5. So this is the difference between this length and the length versus length variable versus length method. So I think that's all with the today's lesson. So the string manipulation. Now for your information, the string and the string buffer class we have discussed on this string and the string buffer class. Now this string and the string buffer class contains number of methods. Okay, so this string and the string buffer class contains number of methods, and it is not possible to discuss all the methods in this class uh, because of the limited time. But I will show you what are the methods that is present in those two classes, and I want you to Google it out or you can explore it yourself. So because there is in one class there is, for example, string class, there is 100 plus methods, and for the object also there is 100 plus methods. So it's not possible to discuss all these methods. So I think you have to Google it out and explore it yourself. So if you are really interested, so some of the methods we have already used it, like equals to string method. There is like compare to method. Also we have also like char, add, reverse, append. We got multiple methods. I have some of them I have already used it. So other remaining methods, I want you to Google it out and explore it yourself. So this is just for your information. So now, before winding up, I just wanted to let you know how to check the various methods which is present in the string and the buffer. Okay. Now the command to check is java p. So if you do java p, now our string class, that is the inbuilt, I mean predefined string class is present in java.lang package, and we have in this java.lang we have a string class. Just give the name of the string, and if you do java p java.lang.string, then if you hit enter, so these are the methods which is present in this string. I just lost it, string. So this is the string, right? So this is the string file, string class. It's just for your understanding I'm showing. So this is the string class, inbuilt string class. Now inside this Java file, that is string class, there is this many methods. So this is the command that you can know the methods which is present in this java.lang.string. So we have multiple methods like string here, string. We have let me see here. We have code point eight, then is empty method, then char eight method, then get car. Multiple methods are here. So like hash code, index of. So these methods you have to explore it yourself because it's very important when you are developing the projects and all. So for this lesson I've used like some of like equals to method and all. So this is how we are checking the methods which is present in the string. And if you want to check the methods for this string buffer, you can do just do java p java dot lang dot, you just give the class name that is string buffer. This string buffer is also here, have string buffer open, so it is in the java.lang package. This is inbuilt. This is string dot buffer. Now inside this string dot buffer there are also number of methods. So this is the command that you use to find the methods which is present in the class, in this string dot buffer class. So if you just hit enter, so this is how. Now inside this string dot buffer class there is multiple methods like append method, then we also have an insert method and all. So multiple methods, 100 plus methods are there. So I want you to explore on these other methods, okay? Because it is important. You have to explore it yourself. This now, for your information, just before this, we have one error that is we are given a null value instead of this our data. So I think I'll come back to you on come back to on that error on next week because I'm also learning and you are also learning. So let's learn together and let's grow together. So I think we are done with today's lesson and thank you for watching. So we will see you in the next lesson. Thank you.